SQL Server statistics are one of the key inputs for the Query Optimizer during generating a query plan. In this video we will learn different parts of statistics and will provide a few examples how they are getting used by Query Optimizer. Here is a simple table with one column. We want to see how statistics getting filled for this column. For simplicity we arrange the rows in a predictable way. So for value 1 here is one row, for value 2 there are 2 rows, and so on until we reach to value 499. To create and fill such a table, following script could be used. If we run a simple select command with where clause that column is involved, then the statistics for that column getting created. With running dbcc show_statistics, the data inside the statistics will be shown. There are 3 sections inside the statistics: header, density vector, and histogram. We will consider all important columns getting used by Query Optimizer. In the header section, the column rows shows the number of the all rows in the table. In the density vector section, the column all density is calculated by dividing 1 to distinct values of the column. In this case, 1 divided to 499. Histogram has 5 columns and maximum of 200 entries could be stored there regardless of number of rows in the table. For null value there is an extra entries. So if there are 1,000 rows or 10 million rows in the table, there will be maximum of 200 entries in the histogram. First column range hi key is the key value for a histogram step. We can see the first values is 1, next 22, 35, and so on until we reach to 499. The column range rows is estimated number of rows whose column value falls within a histogram step, excluding the key value itself. So between the values 1 and 22 there are estimated 230 rows. The third column, eq rows or equal row, is estimated number of rows whose column value equals the key value of the histogram step. For example, for the key value 22 there are 22 rows. Next column, the distinct range rows, is estimated number of rows with a distinct column value within a histogram step, excluding the key value itself. For example, between the values 1 and 22 there are 20 distinct number. Last column, the AVG range rows, is average number of rows calculated by dividing range rows by distinct range rows. When distinct range rows is 0, average range rows returns 1. For second row we can divide 230 T020 is equal to 11.5. Now let's see how Query Optimizer is using these data if we run flowing query. The estimated number of rows per execution is 1176. Here is how 1176 getting out from histogram. The first range high key less than 49 is 48 in the histogram. Let's try another query. We are looking for all rows equal greater than 495. The estimated number of rows per execution is 1986. Here is how 1986 getting out from histogram. With following query, the estimated number of rows per execution is 28.5. That come directly from average range rows, the key between 23 and 34. Let's execute same query with optimize for unknown hint. We can see this time density vector getting used for calculation by multiplying all density to number of rows of the table. Algorithms used for performing the cardinality estimation could be printed by using undocumented trace flags 2363 and 3604. Learning all algorithms and how they are getting used by Query Optimizer could be really time-consuming. What is important, we make sure the data in statistics histogram is in a way it result in fast execution plan. By adjusting sampling rate in the process of statistics update we can achieve that. For highly skewed data, the filtered statistics could be the best option.